Alright, hi year 12s, this is Mr. Lim here again, and this is our equilibrium video on changes to temperature. Let's get started. Okay, so we're going to be learning about endo and exothermic reactions. This is just a bit of a refresher about how to tell if something's endo or exothermic, and if you can't do that, then we're in trouble. Alright, so let's have a look. First of all, you need to be able to identify if a reaction is endothermic or exothermic via if it's given a delta H. Okay, so say you have some reactants, they turn into products here. Okay, the delta H is always shown on the right hand side after one of these semicolons. All right, and then it's equals, I don't know, 84 kilojoules. And if it's a negative value, then it's an exothermic reaction, and if it's a positive value, it's an endothermic reaction. But what you really need to remember is to look for this semicolon, to look for this delta H equals something. All right, that's how you know that you've been given a reaction where you've been given delta H as a value rather than delta H within a reaction. All right, let's move on. The next is ways to identify if a reaction is endo or exothermic via energy as a reactant or a product. Okay, so this is going to look the same but be different. Okay, so let's go and reactants going to products. Now, in the last example, you were given delta H on the side after a semicolon. But sometimes you're just going to be given the heat in the reaction. Okay, so what you'll see immediately preceding the value is a plus, but there'll be no separation by a semicolon, there'll be no delta H, whatever. All right, so you could have a plus heat, you could have a plus a value, all right? A plus value, so maybe 86 kilojoules, or you might even have a positive delta H, or just like a plus delta H, something, all right? So you could have the word heat, you could have a value, or you could have delta H. And that would mean that that is inside the reaction because there's no semicolon there. All right, so if the heat is shown as a reactant, so that's on this side, then it's endothermic. If it's shown on as a product, then it's an exothermic. So this is an exothermic if the heat is on the right-hand side. This is also exothermic, and this is also exothermic. All right? So as long as it's on the right-hand side, it's exothermic. If it's on the left-hand side, it's endothermic. All right? And then finally, you have to work out from energy profile diagrams. Okay, so first of all, let's go think about what are the labels here. Axis labels on the top is the enthalpy. Enthalpy shown as H, or chemical potential energy. On the bottom, is it time? No, it's progress of reaction. Why is it progress of reaction and not time? Okay, because the time that it takes from a reactant to go to a product is almost instantaneous, so therefore it's not to scale, so therefore it's not time. All right, what we're looking for is that if the reactants are higher than the products, okay, if the reactants are higher than the product, then this is an exothermic reaction. If the reactants are lower than the products, then this is an endothermic reaction. Okay, so this is all stuff from ages ago, but this is just stuff that we have to cover just to make sure that you can pick out what's an endo or exothermic reaction. That's all.